Hello, my name is Q Tucker, and I am the Commissioner of the North Carolina High School Athletic Association. As you know, substandard lighting on a field, court, or in a gymnasium can be a serious liability issue for schools and school systems. Since the early 1990s, when the NCHSAA lighting standards were adopted, Musco representatives like Dina Neely and Brad Marloff, with support from Mike Limpak, have offered and provided lighting system assessments and analysis of member school facilities free of charge. After years of discussion about lighting standards and enforcement, this past May, the Board of Directors recommended each member school conduct safety checks on all lighting systems. This recommendation becomes an annual requirement in the year 2021-2022 prior to any school hosting playoff events. These are important system checkups that are designed to help you ensure the safest operation of your system and venue. Musco has been kind enough to provide us with a few instructional videos to help you or your maintenance team conduct these required safety checks. We all must do our part to ensure the safety of our students, coaches, and patrons. Thank you for your attention, and thank you to our friends at Musco.
Conducting safety and performance testing of your lighting system is important for a number of reasons. First, you want to make sure there are no potential safety issues that, if left unchecked, could harm players, coaches, and spectators. Second, you want to provide the best possible visibility, playability, and overall positive game atmosphere for your athletic fields. And third, the North Carolina High School Athletic Association has mandated that beginning next year, any school hosting a playoff game at their home field must have a safety and performance inspection completed and on file with the association.
So in order to help athletic directors, maintenance, and other school personnel work through this mandate and meet the requirements, Musco Sports Lighting will assist you in demonstrating detailed steps of how to work through the safety and performance checklist.
Inspecting your lighting system's poles is vital in order to ensure correct structural integrity, safety at your facility, and monitor how they're holding up to environmental elements like wind and water. Most poles are constructed of either wood, concrete, or steel. There are two key steps in checking your poles: a visual inspection and then a more comprehensive physical testing depending on what type of poles you're working with. If your facility has wood poles, it's important to look for any signs of leaning, cracking, or twisting, which is fairly common for wood poles as they age. Twisting of poles, which is evident by seeing large spiraling vertical cracks, reduce the core strength of the pole. When leaning or twisting occurs, it affects the alignment of the luminaires and can reduce the light levels being achieved on the field of play. Once you check for leaning, twisting, or cracking, move on to the condition of the wood pole itself by checking the base of the pole for deterioration. To do this, drive a screwdriver into the base of the pole at ground level. This is the area of the wood pole most susceptible to decay and stress from the wind, so you want to check to see if there are any signs of rotting or deterioration. If you are unsure about the results you're seeing, consider bringing in a third-party professional to conduct further testing and provide a full report on the condition of your wood poles. Alternative to wood poles are those made of concrete and steel. With steel poles, there are three approaches to the installation. One is burying the base of the pole beneath grade, while the other involves using anchor bolts to attach the base of the pole to a pre-poured concrete foundation. A third would be a pre-stressed concrete foundation where the steel pole slip fits over the top of the pole. For your visual inspection, there are a number of components that you'll want to focus on. Check for any signs of corrosion or rust, bleeding on the mounting arms, pole shaft, base plates, and anchor bolts, depending on how your poles have been installed. You'll also want to inspect welds and wire access openings for corrosion, rust bleeding, or other signs of metal fatigue. Try turning nuts to check for looseness. Make sure external cable conduits aren't cracked or missing, and make sure all the pole's electrical access covers are in place. And some poles might have climbing steps and safety cable that was prevalent on poles installed 15 years ago. With easier access to lifts and bucket trucks today, as well as restrictions imposed by insurance companies on the climbing of poles, the use of this equipment has been greatly reduced. However, it's still important to inspect these components if they're part of your pole structures to ensure they're properly attached, aligned, and free of decay and corrosion for liability purposes. And while concrete and steel poles installed beneath grade with properly designed foundations shouldn't have any issues with leaning or twisting, some facilities have poles that have been buried directly into the ground without a properly designed foundation. So as with wood poles, you want to check with signs of misalignment of your poles. In addition to visually inspecting everything on your poles above grade, it's critical to check what's happening below grade. Another major problem that can occur at the base of direct buried steel poles is corrosion from groundwater tables that can raise the level of moisture on the exterior and on the interior of the pole. Some direct buried steel poles feature a protective mastic coating just above and below grade at the base where the pole enters the ground. For these, you'll want to make sure there's proper amount of mastic coating above grade and outside of the pole to ensure no corrosion or pitting of the galvanized coating is occurring. It's also important to inspect the inside of the pole at or below ground level for any signs of corrosion. You can visually check by scratching some of the dirt back from the base of a direct buried steel pole and look for pitting, rust, and missing galvanization or mastic coating. Take the handhole cover off and inspect the inside of the pole to ensure there is coating present at a height located above groundwater and that there is no corrosion. Conducting visual and a thorough inspection of your poles every year is a good way to stay ahead of any problems that may occur. And if you see any red flags in terms of corrosion, fatigue, or other areas, you should call in a professional inspection company to conduct more extensive testing and resolve any problems. However, there are structural integrity issues such as weld fatigue, galvanized thickness, and corrosion on the interior of the pole that may not be visible during a visual inspection. Most corrosion occurs from the inside out, so if you're seeing even a little corrosion, rust, or fatigue during your visual inspection, it could be the sign of a larger problem happening internally. This is where advanced physical inspection should occur when you see signs of corrosion. However, a test every 4 years should be a part of your routine maintenance. This advanced testing involves non-destructive testing using ultrasonic, magnetic particle, and dye penetrant technologies. It's used to help determine if there is corrosion of any other areas of concern within the walls or foundation of your poles, as well as with bolts and welds on the structure. Professionals such as EXO or Valmont would be an example of an appropriate testing service. Ensuring the safety and structural integrity of your sports lighting poles is crucial in order to avoid the significant damage that structure failures can create. Inspecting your pole structures annually is part of your safety checklist requirements.
When it comes to inspecting the performance of your luminaires, you're going to be looking at the condition of the luminaires as well as their aiming angles. If you're using a bucket truck or lift for fuse inspection or other top of the pole services, you can use that to check your luminaires at the same time. But if your system utilizes electrical components that are located remotely, you can complete the luminaire inspection from ground level using binoculars. The first thing you'll want to check is to see if any of your luminaires aren't operating. If you see an outage, it will require further testing. With drivers or ballast systems located remotely from the luminaire assembly, troubleshooting can be done using a stepladder. If the drivers or ballasts are integrated into the fixtures, the outage could be caused by a bad lamp, faulty capacitor, ballast or driver, fuse, or surge protection device. In most cases, with integrated drivers or ballasts where the work needs to be done at the top of the pole, a contractor will need to be hired. When you start the visual inspection of the fixtures, look for any cloudiness on the lenses, which can result from dirt or gases inside the optics that cloud the inside of the fixture. If your lenses show sign of cloudiness, it could block light output and affect your light levels on the field. Additionally, water can seep into the luminaire housing, which should be visible from the ground level. From there, you'll want to check the aiming alignment of the luminaires. Aiming angles are critical in achieving the necessary light standards, and over time they can be affected by things like pole leaning, twisting, among other factors. Visually inspect the luminaires for any sign of misalignment, which could include tilting down, tilting up, or aiming into another fixture. If you see any luminaires showing signs of misalignment, corrective action will need to be taken. Typically, this involves using a lift and re-aiming to the original specifications in order to meet the necessary lighting standards. It's important to remember that regularly scheduled maintenance of your luminaires can help prevent problems from arising. Periodic cleaning of the lenses and optics will result in optimum performance of the luminaire. Those steps, along with this inspection checklist, will help ensure that your luminaires are performing at an optimum level.
Many of these items on the checklist should be performed by a qualified electrician. Greg Newell will take us through testing many items on that checklist.
Stray voltage can occur on any conductive material. For example, fences, metal poles, aluminum bleachers. This can be found and isolated through a process that needs to be performed by qualified electrical personnel. Inspecting your facility service entrance, poles, and distribution boxes is critical because these are where some of the most potential hazardous safety issues can arise. Moving on to your electrical service, which includes metering, your electrical panel or panels, and your lighting controls. When you inspect your electrical service, you want to make sure that all covers are in place and that it is secure from unauthorized personnel. Also, make sure that all labels are properly installed. This is an example of proper external panel labeling. It should include the name of the project, the address of the project, the panel name, the voltage and phase, the wire coloring, where this panel is fed from, the AIC rating of the panel, the available AIC rating, and who determined the AIC rating, whether it be the power company or an electrical engineer. This panel has its cover in place, all screws are intact, a lock to prevent it from being accessed from unauthorized personnel, circuit directory, safety labeling, including arc flash. Circuit breakers are not to be used for continuous controlling of your lighting system. There's a misconception that circuit breakers that are labeled SWD or HID are rated for switching. And they are, but not for continuous switching for daily operation of lighting systems. They are intended to be able to break the circuit under load for routine maintenance, which takes place periodically. Testing your circuit breakers is important. The proper way to do that to prevent possible arc flash is to turn your main breaker off first, then move through each circuit breaker, flipping it on and off a couple of times, making sure that it snaps in place and holds. Next, turn your main breaker back on. Before you do so, turn all of your branch circuit breakers off, turn your main breaker on, and then one at a time, turn your branch circuit breakers back on. Lighting contactors are the preferred method for controlling your lighting system. They can be controlled by either an on-site switch or a wireless remote control system. Moving on to our lighting control cabinet, which houses our lighting contactors. You can see the cover is in place. It has a lockable door where a padlock can be inserted. We've removed it. External key switches for manual operation and auto operation. Arc flash warning. Everything is neatly secured, wired, and in place so that you don't have potential for damaged wiring or excess stress on terminal points that could cause loose connections and heating of the wire. A well-designed control system will have internal surge protection as well as fusing. This system has a red window that will illuminate in the event of a blown fuse. If your service is located outdoors and has a receptacle on it, it should be GFCI rated and weather rated, and also have a heavy-duty, non-accessible cover. Fuses are an important part of your lighting system safety. They protect individual components of your lighting system that isolates and prevents gang failure. A first indicator that you may have a blown fuse is a light being out. Fuses can be located in several locations on your lighting pole. For systems with remote located ballasts and drivers, the fuses will be located approximately 8 to 10 feet off the ground in those cabinets. In other systems where the ballast and the driver is located integral, the fuses will be mounted and located at the top of the pole. Some manufacturers don't install fuses at all. Again, to reinforce the importance of fuses, they protect individual components of the lighting system, such as ballasts and drivers. This isolates a problem to one fixture and prevents a complete pole outage. Another component that could cause an outage is a faulted surge protection device. With newer systems, surge protection devices, sometimes referred to as SPDs, are integrated into the system due to the sensitivity of the electronics of LED drivers and such. These SPDs can be located often remotely in a cabinet 8 to 10 feet off the ground. Depending on the manufacturer, they may be located in the fixture at the top of the pole. During your inspection process, you want to visually look and inspect these SPDs to see if they have faulted. As you move along with your inspection, you always want to visually inspect your wiring. Look for cracked or damaged insulation and also discoloring. Discoloring is caused from heat, which usually leads to a loose or defective termination, which could be a termination on a circuit breaker, in a wire nut, Polaris block, etc.
When it comes to testing your system's on-field lighting performance, the goal is to ensure that it's meeting North Carolina High School Athletic Association standards in terms of quantity and quality. Quantity of light refers to the light levels, which are determined by the units of measurements called foot candles that are being achieved across the field. Quality of light refers to uniformity, which can be determined by comparing the number of foot candles in one area to the number in adjacent areas and the overall smoothness of light distribution. Now I'm going to demonstrate the process for testing your field for light levels and uniformity. Again, light quantity is measured in foot candles, and for a high school football or soccer field, you should achieve an average of 50 foot candles. The first step is making sure you have a calibrated light meter, which is used to measure light levels. Next, you'll need to make sure the field is properly gridded out. To grid a field, you'll need a few tape measures and some cones or flags. Whatever type of field you're measuring should be gridded out with the flags or cones in accordance with the standard for that sport. For example, on a soccer field with playing dimensions of 360 feet by 225 feet, each flag or grid point should be placed 30 feet apart from those adjacent to it in all directions. This will result in approximately 90 grid points across the field, and it will create square grid spaces of 30 feet by 30 feet, from which the foot candle readings will be taken. Each field you're measuring has a unique grid pattern depending on its size and dimensions. For example, a baseball field is going to have different dimensions based on the outfield than a softball field. Once your field is properly gridded out, you'll be ready to begin taking light level readings. A form for capturing the readings has been provided to you, which will simplify inputting the data and calculating the values. When it comes time to take the light level readings from each grid space, hold the light meter 3 feet off the ground, making sure it's level and parallel with the playing surface. Be careful not to tilt the meter towards the light or cast shadows onto the grid space that's being measured. Record each reading as you move throughout the grid spaces across the field. Use the form we've provided to calculate the average light levels and uniformities. Once all the readings have been captured and calculated, you'll be able to compare your results to the specified values in the North Carolina High School Athletic Association's lighting standards. I hope this video has been helpful to you as you begin your testing program. Our goal is to ensure player and spectator safety and ensure that you're in compliance with all lighting standards.